a rational exponent and the nth roots. You could take any root, whether it's 5th root, 7th root, 9th root, and it'll be the denominator of a fraction and the exponent. Now we already knew that. We already said that the square root could be rewritten as the 1/2 power. Now remember, there's a 2 right here. That's why there's a denominator of 2. Or we also said the cube root is really the same thing as the 1/3 power. Once again, the root becomes the denominator on the power. So the root becomes the denominator on the power. And the power becomes the numerator on the power. Okay? So that's just something that will help you rewrite radicals to rational exponents, and also rewriting rational exponents to radicals. Let me give you an example of that. Everybody copy down x to the 2/3 power. There will be a portion on the test, 4 questions only. There's a portion on your homework today where you need to take this and rewrite this exponent, this rational exponent, as a radical. So how am I going to write this as a radical? Remember, the denominator is the root. So what kind of root are we going to be dealing with? Cube root, right? The 3rd root. So let's start by writing the 3rd root. And what about the power right here? Where does that go? That goes on the inside with the base and just the power. The base is x, the power is 2. So on the inside, it's just x squared. And that's your answer right there. So like I said, there's going to be some really easy questions on the test. All you got to do is understand this, how to rewrite it, how to switch it up. Okay? Now, what if I had something like this? How about the square root of 18x? Now, I'm not asking you to simplify. I want you to rewrite as rational exponent. I'm not asking you to simplify. I'm asking you to rewrite it as a rational exponent. So what kind of root do we have here? Square root. So where is this 2 going to go? The denominator, right? Now, what is the base in here? 18x. Very important that we include the 18 and the x together. So as a rational exponent, you need to put 18x inside parentheses. Now, what kind of power do we have? 1/2 power. That's right. So the power is 1/2. And that's your answer for that one.
So when it says square root, you have to put parentheses or every time?
If you have the square root of 18x, you have to put this in parentheses to show that all of this is inside the square root. And let me give you a couple more examples and you'll see the difference. Everybody copy that one down. 25x to the 1/2 power. This is a curveball. It's so easy you might get confused. I want you to rewrite as a radical. Man, I can't spell. Radical. So what would this be as a radical? It's going to be a square root. See? Curveball. What has the power of 1/2? The x only, right? Now notice, because you guys just asked, does parentheses make a difference? I don't have parentheses here, okay? I don't have parentheses. So the only thing that has the 1/2 power is the x. So the 25 is just 25 times x to the 1/2. So my real answer as a radical, rewritten as a radical, it would be 25 square root of x. You don't mess with the 25. Now there's a big difference if I would say, what is 25x to the 1/2 power? Then yeah, right there for sure, the square root of 25x. So on this section of our homework, on this section of the class, we are not going to simplify. Notice what it says up here. It says rewrite each expression in radical form or rewrite each radical in exponential form. So we do have the square root of 15x. They don't actually want us to do it. You don't have to think about perfect square numbers. You don't have to rewrite it with multiplication. You don't have to break it down. You don't have to split the roots. All you have to do is take the radical and rewrite it as an exponent. Or take the exponent and rewrite it as a radical. All we're doing is rewriting. So this section, honestly, is the easiest section. Okay, because you're not really doing math, you're just rewriting. And if you know the pattern that I wrote on the other page, let me write it down here. The R root of whatever base to whatever power, you're going to be able to rewrite it as the base to the power over root. That's the pattern that you guys need to have memorized right here. Okay, so what do we have up here? We have 15x and the square root of it. So what is the square root? It's really the power of what? 1/2. So I'm going to take the whole thing, 15x, and I'm going to rewrite it as 15x to the power of 1/2. And that's it. Done. Nothing else to do. Easy peasy, lemon squeezy. Okay? How about number 2? Do I have a square root symbol here or a radical here? No, I have an exponent of 1/2. So I need to change it to look like a root. So first you have to ask yourself, does the whole thing have the power of 1/2? No. Only the z has the power of 1/2. This 16 is just 16 times z to the 1/2. So keep that in mind. This says 16 times z, so let's rewrite it as 16 times, but let me change z to the 1/2 as what? To a square root. Square root of z. And that's your answer right there, guys. 16 square root of z. 1/2 is a square root. 1/3 is the third root. 1/4 is the fourth root. 1/5 is the fifth root. Or vice versa. If I say the third root, that's really the 1/3 power. If I say the fifth root, that's really the 1/5 power. If I say the square root, that's really the 1/2 power, right? So over here, I have x to the 2/3 power. I think we already explained this on the previous slide. I need to rewrite it as a radical. Now, on the notes that you should have memorized already, where's the root at? Is it on the numerator or the denominator? The denominator. So what kind of root do we have here? Cube root, third root, or the root 3. So let's start by putting that 3 right there. And on the inside, what do we have? Obviously, x and the power of 2. And that's it. You're done. There's no math to do. Okay? How about number 4? What do we have on number 4? We have the fifth root of this whole thing. I mean, 7x to the 4th, all of it is inside the radical. So if I want to rewrite it, I want to rewrite all of it, but as to the 1/5 power. So what's in there? 7x to the 4th. We don't have to do any math. That's it. You're just rewriting from radical to exponential, or from exponential to radical. Number 5 has a number 2 out in front that's being multiplied, right? Now this whole thing, 3x squared y, is inside the third root, but I'm going to change the third root to be what kind of power? You guys already know what the third root is. It's the power of what? 1/3. The power of 1/3. And that's it. Why? Because they're not asking us to simplify. We don't have to do any math. All we're doing, look at the instructions, it says rewrite. Rewrite. In radical form or exponential form. It depends what, like right here you had a square root, you ended up with an exponent. Right here you had an exponent, you ended up with the square root. There's going to be 4 questions like this, easy stuff on the test, but you guys need to know how to do this, okay? So what we've been practicing is actually the first half of today's homework. So I hope everybody has their homework, and now we're able to understand it. Numbers 1 through 18 is what we're doing today. Tomorrow we're going to do the bottom part where we actually have to solve equations that have variables in the exponent. So up here, all we have to do, as you could see on the instructions, the same thing we were doing on the previous slide, rewrite each expression in radical form. So here we have a rational exponent. We want to write it as a radical. What is the power of 1/2 really? The power of 1/2 is a square root. That's right. So rewriting it, it would just be the square root of 8x. And that's it. I mean, I don't have to simplify this. If it said simplify, then I would rewrite 8 as 4 times 2, split the root, do the square root of 4. See what I mean? But they're not asking us to simplify. They're just asking us to rewrite it from exponential to radical, or from radical to exponential. So on number 4, it's a radical. I want to rewrite that as an exponential. So if I wanted to rewrite number 4 as an exponent, that would be the number 11 to what power? To the power of 1/2, because that's the square root right here on number 4, square root. Could put a little invisible 2 if you want, but that's the power of 1/2. Make sense? Yeah. So all we're doing is rewriting from radical to rational exponent, or from exponential back to radical. Let's all take a look at number 7, since it's right here on the screen. You see this whole thing, 27g? That whole thing is inside the square root. Now, they're not asking us to simplify. If they were asking us to simplify, I would rewrite 27 as 9 times 3. That way I could do the square root of 9. But they're not asking us to do that. Yeah. They just want us to rewrite the whole thing as a rational exponent. So if the whole thing, 27g, is in there in the square root, I want to rewrite it as 27g, all in parentheses, to the 1/2 power, and I'm done. Yeah. And you guys have the answers on the back. Turn it around, check it, you'll see that it's right. Yeah. Let's move on to number 2, 5, and 8. Number 2, I need to rewrite that as a radical, but keep in mind, what is the only term that has the power of 1/2? The variable z. So the 6 that's out here in the front, it's just saying 6 times z to the 1/2. So my answer, rewritten in radical form, is 6 times the square root of z. Because remember, z to the 1/2, that's really the square root of z. And the 6 that's out in front, you just put it out in front. Now, if the whole thing had parentheses around the 6z, then yes, it would be the square root of 6z. You guys know what I'm talking about? Yeah. Number 5, what's the only thing with the square root? The x. That's really, x to the 1/2 is really the square root of x. Now, what about the 19? Put it in front. How about number 8? What's the only thing with the square root? The h. So that's really the square root of h. And what about everything else? Put it in front. Stays the same. And like I said, we're not even simplifying here. We're just rewriting. Yes. Let's do number 3. The square root of 19. I want to write it as a rational exponent. That 19, I want to rewrite it as 19 to the 1/2. Done. Easy. Number 6, what's the answer there? 34 to the 1/2. And you could put in parentheses if you want. You don't need them. How about number 9? That whole thing, 13abc to the 1/2. You see, it's easy. Now, this other part is kind of challenging. Like number 10, we know that 1/4 is really the 4th root, right? Yeah. So I could, like if this confuses you, I could rewrite it as the 4th root of 1/16. And we know that we could split the root and say the 4th root of 1 over the 4th root of 16. And then you could actually do the 4th root of 1. What is the 4th root of 1? 1, because 1 times 1 times 1 times 1, 4 times gives you just 1. So the answer is 1 up on top. And what's the 4th root of 16? 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So your answer is 1/2. Yeah, but you want, it's the 4th root. So what times itself 4 times gives you 16? That'd be 4. Okay, I get you. Now there's other ways of doing this problem.
Yeah, it's because I saw the 4.
Let's all take a look at number 11. Now, one way of doing this is knowing that you want the 5th root of this huge number. So you want to think of a number times itself 5 times. So you could get a calculator and just pick a number like 7 to the 5th power and see if it actually gives you 3,125. Or you could try 6 to the 5th power, see if it gives you 3,125. right? You could do that with the calculator. Now the Casios, Janisa, the Casios are like way more advanced than the other ones. Check this out. Do you guys see this right here?
Yes.
There's a square right here where the root's at, and there's a blank spot inside the root. So guess what? If, in order for me to hit this, I need to hit the shift button, which is this guy, shift, hit that button, and then this one, and it'll actually do the brown one. Now when I do shift and then X, you will see that.
Yeah.
Now if you want to do the fifth root of 3,125, all you got to do is type in a 5 right here and 3,125. And when you do that, when you type in the fifth root and 3,125 and then hit equal, it'll give you the answer 5. And that's it. Now, because of the Casios being able to simplify any regular root that does not have variables, I'm not going to be putting too many of those on the test Friday. I want to put ones that actually have variables because the calculator cannot do the variables. But anyways, you could type this into the calculator and get 5. Okay? You could also even type in this into the calculator. 729, if you were to type in 729 using this button, x to the something power, so you could type in 729, and then up there when it opens up the little box, all you have to do is type in 1/3 power, which means 1 divided by 3. Hit equal, it'll give you the answer 9. So this answer right here on number 12 is 9. You could do any of these without variables on the calculator, but I'm telling you, you're not really going to see these without variables on the test because I know that somebody could just use the calculator and get all the answers. So what am I indirectly telling you? You don't really have to study these because since the calculator does them for you, I'm not going to ask them on the test. Okay? So I highly recommend you watch the other videos. And we'll pick it up right here tomorrow. This is important, this first part, because it has variables in it and you're changing from rational exponents to radicals or from radicals back to rational exponents. That does come out on the test. But these guys down here, since the calculator could do all of them, we're not going to really have 10 through 18 on the test. But we will have solving all of this bottom portion that we're going to be doing tomorrow. This will be on the test Friday, and that's it.